Alright, welcome back to another OUGDA tutorial. This is going to be part 3, and we're going to focus on rigging today, rigging of this character. I don't want to get into facial rigging, that could be its own video, so if there is a request for it, then just say so, and I'll work on that. But right now I'm just going to do a basic rig setup with sticky feet and show you how to set up controls for the arms, the back, and the head and hips. So to start, we want to switch to the animation tab, and we're going to go to skeleton and grab the joint tool. Oh, well, first we want to make sure that all of our transformations are frozen and history is deleted. That's very important. Whenever you start rigging, you can no longer change the mesh once your character has been rigged. So you need to make sure that everything's finalized and all your history is deleted. I should probably name them too. That's just good practice. So I'm going to go into my side view here, and using the skeleton joint tool, I'm going to place his root joint or his hip joint. So right here, right around where the pelvis joint should be. And then from that, I'm going to go up the back. Now, if you think about the way that your back bends, there are a lot of vertebrae in your back. But really, it only bends from the bottom, probably third of your entire back. So we're going to want to put a couple of joints down here, and then it's going to come up a lot further because your ribs don't really bend. And then we're going to have the root for the clavicle, for where the shoulders are going to come out at. That should probably be a little bit higher. So. And then the base of the neck, the top of the neck, and then I always just pull one up straight to the top of the head. It's the cranium. Okay, so now I'm going to go back and rename these, and since I did them from the side view, they're automatically going to be snapped directly to the grid in the center. So we'll name this one root joint. And afterwards you can use the modify prefix hierarchy names and put a prefix in front of them. So I'm just going to call all of them the kid root joint. So you know, whatever your character's named, you can just do that once you're done. So right now I'm not going to worry about that. That's after you're completely finished. So then we can name this lower back 1, lower back 2, and this should probably be, I'm going to hold in D and move this one down a little bit lower. If you hold in D, you can move the position of a joint without interfering with the ones up the hierarchy. Without holding in D, it'll move all the joints above it. So while holding in, I can slide this joint around freely. I'm just going to bring it down a little bit lower, about the bottom of where the rib should be, and call this one mid back joint. I'm not really sticking to strict naming conventions right now, but it's good practice to do so. Bring this one down a little bit. This one's not really going to bend, it's just going to be where the arms come out at. So it's upper back joint. This is lower neck, and the upper neck. And now, if, say, we want this character to have some facial animation but not much, I can cover a little bit of that right now. And generally what you would want is to have another joint in between here, so we can go to the joints, or skeleton selection, insert joint tool, and if I just click on this, let me go to the side view. So if I just click anywhere on this joint chain, I'm going to be adding a new one in the middle of it. And what I can do here, because I want this joint to be the rotation of the entire head, so the upper neck, where you tilt your head and where it angles from. But this one, I want to be the root of all the facial rig. So I can move it and the cranium a little bit to get them more in a position that I like them. Because then from this one, what I can do, let's go back to my joint tool, select this one to come off of, and then I can come down to the jaw and then out to the chin. And what you can see, if you pay attention to this joint right here as I'm drawing these, you can see that Maya automatically orients joints. So watch right now, as soon as I release, it pops it into orient towards this last joint. So now if I go into my attribute editor and look at this joint right here, its orientation under the attribute editor for this joint, you can go down to joint orient. This orientation is way off because it doesn't have another joint to connect to. Since it's the end of the chain, it doesn't matter a whole lot, but you pretty much always want to make sure that you're paying attention to these orientations, and keep them nice and clean. Whenever you're rigging or setting up a joint chain, you should never rotate the joint with the rotation tool. You always change its orientation with the joint orientation numbers right here. These numbers will rotate the joints the same way that you do with the rotate tool, but you have to do it all by numbers. So say we want this to be more round at 120, that's fine. But if you change this value up here, you cannot freeze transformations on a joint and keep the animation working properly. Whenever you freeze the transformations, it actually resets the joint orientation, as you can see. I just hit G, repeat. So it actually changes the joint orientation, and that's terrible for creating bind poses for your characters and doing any kind of animation. It can really mess you up on down the road. So it's just something to keep in mind. So right now I'm just going to keep this here. We'll just do a chin, and I'll show you how to do eyes as well. So we can just bring this joint up, and I want to line it up with being dead center with the sphere that I created for the eyes. So line it up at the top and the sides. Make sure its orientations are all zeroed out. Oh, something seems wrong. And also, in case you didn't notice, I have combined all of the mesh into one solid mesh now. And we're sitting around 7,000 tries. That's pretty good for this character. So we have this joint sitting right in the middle of the eye, so we'll call this one left eye joint. We'll call this the head root joint. And this one we already named. So then we have the jaw root, or jaw joint, I guess. And this is the chin joint. Chin joint isn't really going to do anything, it's just the end of the jaw joint chain to identify which direction this joint is facing and which way it's going to rotate. And then we have the cranium. Let's zero these out. Okay, so we have all of our joint chain so far named, and I'm going to go ahead and do one of the legs now. And just like with modeling, you can just model half and then duplicate. You can mirror your rig as well, or you can mirror your skeleton for the rig, your joints. Mirroring constraints does not work quite the same. Just space these out a little bit better once I'm looking at the front view. They don't look quite right. So for the right or left leg, my right now, I'm going to start with the hip, which should usually fall further to the side of the leg. Your hip bone actually sits almost directly against the skin. You can feel your hip bone more than any other bone in your leg. Then it comes back inwards a little bit for the knee, actually. And then we go straight down to the ankle. And we want to put these joints right where we think that it's going to bend the most. So Then I'm going to jump into my side view and adjust these to better fit the mesh. So obviously the knee needs to come forward, and the ankle, bring that back. Now the reason this time I didn't just use D to move it is because it wouldn't reorient the joints automatically if I had done that. I'm actually not liking the way that these orientations are looking. So I'm going to do it myself real quick. Oop, so negative 90. Yeah, that's fine. We don't need it to curve too much. Okay. Why is it doing that? That's odd. There we go. For some reason, I just wanted to try to put an extra spin on that for some unknown reason to me. I don't understand why it's wanting to rotate that either. Alright, whatever. We'll work with it. So then I want to snap this directly to the center of the foot, of the ankle as well. Your ankle mostly bends from the center because it can rotate forward or backwards, but usually this will work pretty good. And then from there, what we want to do is hit Y to get our tool back. Whatever tool is currently over here in the slot that you last used, Y is the quick the hotkey to get that tool back. And then what we're going to do is come back for the heel, and then hold in Shift to go straight forward. If you hold in Shift, it makes a straight line for the ball of the foot, and then another one for the toe, the tip of the foot. And on this one, it's going to be a little bit off because his foot is rotated slightly to the side. So what we can do is actually apply rotation to the Y of the heel of the foot, no, we want to do it to the ball, sorry. So what I'm going to do is rotate it on the Y just to see, or the X, I'm sorry, it's on a different axis right now. So we're going to rotate it on X just to see what value we should probably put in, and then I'll zero that out and come down to the joint orientation and put in about the same thing. So let's try 10.5. Oh, but it should be negative. My bad. Okay. And then on Z, to get it to flatten back out, we'll go around 25. Okay. Then zero these out. Snap it, possibly. So I'm just holding in V to snap the joints to each other and then realigning them to be flat. Just a little bit easier that way. Oh, but guess what? Yeah, I messed up. Okay, so let me undo some stuff. Alright, we're just going to make this 188. Call that good. The rig should work since his feet are so small. I don't think you'll notice, but they'll be a little bit. He'll be walking a little bit with penguin feet, but not majorly. Okay, so that's fine, and we're going to go ahead and name all these again. So we're I'm going to do left hip joint, left knee, left heel, left ball. Put the joint after this. Yes. Left toe. Okay. And select the hip, shift select the root, parent those just by hitting P. So now it's actually connected to the hierarchy. So if we hit select the root, we're selecting everything. Okay, so we're going to do the same job here on the left arm. So go to the front view, we'll place our shoulder. Usually want to place the shoulder pretty high on the arm. It's not actually in the middle, otherwise you won't get a good deformation from the armpit. So go to the midway point where the elbow should be. And then down to the wrist. And then what I usually do is a hand root joint. And I'm going to zero this one out so the hand root is just directly out from the wrist. It's just with the way that I rig an arm with IK constraints, it works best if you have a separate joint for the finger joints to come out of, instead of coming directly out of the wrist. So then, yeah, I can go ahead and do the fingers as well. So from that, I can just come straight out. And I want the fingers to be as straight as possible right now. I can adjust them as needed. So I'm just hitting tab to toggle between the options and the joint orientation. Okay. Alright, and I know that the whole arm needs to come back a little bit more. Turn on X-ray real quick. And the elbow is going to have to come back to the back of the arm. Otherwise it might not perform properly. Bring the wrist forward. Okay, and I'm going to rotate the wrist a little bit on the Y, a little bit more. So I'm going to go around 12 or 8, I guess. Yeah. Okay, and then for the middle finger here, we have it going out straight, but I put a little bit of bend to the finger whenever I modeled it. So it's just on the y-axis. I'm going to rotate each one just by a little bit. Negative, dang it. So probably do each one by -5. And that's just going to be so that it fits better with the default pose of the mesh. Okay. It actually looks like it needs to rotate on the X as well, so that it lines up a little bit better. So just rotate it to see about how much up here, so around 20. Okay. And then I can rotate just a little bit more on Z. and then move it up a little bit. And there we go. It looks really centered right now. So move it back towards the back of the finger, the top of the finger, I should say. Okay. And now all I'm going to do for the other two fingers is hit Control D to duplicate, and it'll automatically keep this parenting, and the hierarchy will be the same. So all I need to change is this root joint to help orient the ones out ahead of it. So if I look, I know that I need to rotate more on Z, so we'll bump that up to probably 15. Okay. Looks like it's pretty close. And then we're going to rotate forward a little bit on Y. That's pretty good. A lot of rigging ends up being trial and error, especially with laying down joints. So it does require a lot of patience. But I enjoy it. It's very problem solving centric, so it's good for that kind of work. Okay, so duplicate it again, move it down here for our pinky, and I'll go ahead and zero these out. And this one's going to have to come down quite a bit further. So let's go -20. And since the pinky's shorter, actually the index finger is a little bit shorter too, so I'm going to scale it down a little bit, and it'll pull all the joints a little closer. No, I'm not going to do that. That's bad practice. Don't listen to me. It's best if you shift select up the joint chain and translate on the axis here. It just gives a little bit less space on the chain. So do the same thing here. Okay. And we're going to rotate out a little bit on Y. 7, looks like. Alright, that looks good. Alright, so then we can go ahead and name all these. So we have left shoulder, left elbow, oops, left wrist, Okay, and do the thumb real quick too. Okay, and then grab them. And now, actually, your thumb really only has two positions at the end. So you have 1, 2, 3 joints out here. But this one should actually come down to where your thumb can rotate and sort of cup inside of your hand. So this one needs to move. Just hold in D. I can adjust it. So this one's a lot lower than the other ones. I don't want to orient it back, so I can use the orient joint tool. There we go. It'll automatically just pull it up into the line of the rest of the joints. And I put these ones a little too close. I need to spread them back out. So just bring this back down. I need to rotate on the X a little bit for all of these. Let's just try some numbers out and see what we're getting here. Alright, so 95. Like I said, just trial and error. Just play with it a little bit and figure out what looks the best for the way that a joint's going to move. Alright, so I've played with it a little too much, I think. I'm getting some really weird rotations. So I might need to take some off of the okay. Alright, let me start that over. That was sort of bad. Okay, so I know that I need to rotate a little bit on the X to get this lined up more with the palm of the hand, based upon the X is pointing this way right now. So we'll do -90. trying to see which way it's going. So I want Y pointing to directly up right now. So yeah, so if I can get Y sort of following the shape of the thumb, just keep going a little bit forward further, and now I'm going to rotate on Z, wrong direction. Okay, there we go. Alright, so now we have left thumb root. Alright, so now we have each side pretty much done. I just need the clavicle joint, which defines the shoulder blade. So I usually prefer it to be completely level. That way, that way I can rotate just on the Y to get a nice shoulder shrug with a Z, or some movement with the Y-axis here. And then I'll just parent that to the upper back joint. So then I can name this left clavicle joint. Should always put the suffix after. I sometimes forget. So I'm going to pull that over a little bit further this way and go into the perspective and bring it back towards the back where the joint actually should exist. And now again, there's some more complex rigging things that could go into this model, but I might save them for another tutorial if anybody else wants to know, like doing a IK spline for the backpack, so you can have some nice balance in it and actually animate it. Right now I'm just going to skin it to the rest of the mesh and it'll be fine. So let's go ahead and duplicate across the axis here. So we're going to go to, after I save real quick, we're going to go to skeleton, mirror joint, and search for the name left underscore and place with right. So this is a really handy function that will help with having, that's why it's important to name everything first. So we want to mirror the behavior, not the orientation. You can do that if you're rigging and you say want the joints to be opposite each other. But if we mirror behavior, what we can get is some nice, oh shoot, I started typing in the field, I didn't want to. If we mirror behavior though, we can mirror movements like this, so it works a lot better. So yeah, that's it. You just over the Y to Z, depending on which direction your character is facing. If he's facing the X direction, you would do it over XY. Basically it. And then do the same for the eyeball. So just hit G, repeat. And there we have our skeleton completely set up. So I can throw the character mesh on a layer here real quick so you can see the skeleton. Looks kind of goofy. Let's check the time. Okay, so now we can go ahead and skin the skeleton to the mesh. So just shift select to get both of them selected, and we're going to go to skin, bind the skin, smooth bind. I'm going to click on the option box here. So we want to bind everything within the joint hierarchy that is currently selected. You can bind to just selected joints, but we don't want to do that right now. Bind method, the closest in hierarchy, yes. So that'll associate each section of the mesh to the joint that is nearest it. It gives us decent default weight paints, but we'll still have to play with it. We want normalized weights to be put on interactive, that way we can actually paint the weights instead of letting Maya automatically assign generic ones that generally don't work. Not for this type of a character, at least, not this low poly and this few of joints. And then max influences. Now what this is doing, it's telling each bone, each vertice how many bones it can be influenced by. So right now, with a max influence of 2, any one vertice can only be influenced by a maximum of 2 joints. So obviously, the more max influences, the smoother your deformation is going to be, and the more you're going to have to weight paint, and it just creates a higher quality result. However, for video games, you want to keep max influences as low as possible, because whenever any animation is playing, it's got to compute how many vertices are moving and play that in real time. 2 is what I've heard is optimal for iOS. 3 or 4 is plenty, and that should be good. That's good for most consoles. So for this character, I'm going to go with 3. He's not going to be on an iOS device at the moment, so that should work, and he's fairly low poly. I can get some good results with this. Drop off rate, the default is 4. That's kind of irrelevant once you start weight painting, actually, because you'll change how things drop off. So we're going to go ahead and hit apply, and now what we can see, if I grab his arm joint here, by the way, joints take precedence in selection, so it's, I think, IK handles, joints, and then curves. So if you just drag select over something, right now it's just going to select the joint, and then I can go ahead and rotate it, and you can see how Maya's default weight paints are working, where it's actually pulling the backpack and his ears moving. So we got some work to do to fix this, because that's not what we want. And just if you check over here, make sure there's nothing before your skin cluster and bind pose, because that's in your history. You want to make sure that it is clean. So we can go back over here, and then the layer, it'll always stay on top no matter what, because you can change those at any time. So that's just important to make sure, because whenever you delete history, it undoes your rig. So you gotta be careful with that. Okay, so now what I'm gonna start doing is just playing around with the weight paints a little bit. So you can also mirror weight paints, so I'm only gonna be working on one side. And I want to work on paint operation add, with a full opacity and full value. And what I can start doing is just painting areas that I want to be influenced by certain joints. So with the root joint selected over here in the paint weights toolbox, we can start painting what the root joint should influence. Now it's gonna go most of his hips here, and I'm gonna go a little bit overboard of where it would naturally go, because since I'm painting on full add, once I get to the next joint, I'll come back through that area and it'll overwrite what I've done with this one. That's why you want to paint on add. You don't want to paint on replace, because it'll try to automatically reassign any weights that are replaced to another joint, and it often will not be a joint that's anywhere near the one you're trying to weight paint. And you can get some really bad results, and you basically will have to start over. Weight painting is a very tedious process, so be warned. So my general approach, though, is just to start on small areas and then go to Edit, Move Skin, Mirror Skin Weights, make sure it's going over the right axis, so X, Y, positive, negative. So positive is, yes, the left side of the character, or the X side. If you look at the compass down here, that is the positive side. So we want positive from right to the left. So apply. Okay. Oh, and it's another important thing to remember. Do not use undo when weight painting. I can show you. I don't know if it'll mess it up right now. But whenever you undo weight paints, what it's actually doing, it just undoes your last move and it doesn't reassign those weights. So sometimes if you undo, you're actually just deleting weights from a vertice, and then you'll be animating later on and notice that, hey, that vertice is not moving at all, no matter what joint I move. Well, that's because you undid. And Maya didn't know what to do with that vertice. So it's just a no-no with weight painting. Okay, so my general approach is paint in all white, so full influence on every area that I know needs to move with that joint. So for instance, the hip, it needs to move everything from the top of the hip down to the top of the knee. And I'm going to make it go ahead and influence the top half of the knee as well. So just along this edge loop here. And then I can go to my knee joint and start down here. And again, this is, I should have mentioned this earlier, but if you hold in B and then click and drag, you can adjust the brush size of the paint weight tool. I believe there's an, yes, no. And there's another option as well, it might be O, no. There is another button to hold in that you can change the opacity just on the fly. I'm not sure what it is. So I'm just going to finish this one leg and then show you how to set up a sticky foot rig, and then I'll probably speed through the rest of this weight painting process. Because it's not that fun to watch, it's not that hard to learn, it's just tedious. So this is for my ankle joint. The heel joint isn't actually going to influence anything. It's really just a placeholder and a pivot point for whenever we set up the foot rig, which you'll see here in a bit. So you don't really need to worry about weight painting that. that joint shouldn't influence any vertices, because it'll never actually rotate. Oh, and that's a very important thing as well I haven't mentioned yet, is joints do not translate whenever you're animating. Everything is done on rotation, unless you have a stretchy rig set up, or there are exceptions to that. I shouldn't say never, but on a character rig, it should almost entirely be just translations. So left heel, we want to empty the ball of the foot. Paint this up to the toe. The toe again is just a placeholder, just to show like where the tip of the foot is, and we'll rotate up on the toe. So okay, hit G to do the mirroring, and I'm just going to check it out by rotating a little bit here. So so it's crunching a little bit, and probably down here too. It's not bad. And another important thing that you can see now is all of my joint rotation values are zeroed out. If, for instance, I'm testing out a pose, testing out my weight paints, and I need to go back to the bind pose, you just zero everything out. So that's another reason why it's important to not mess with those whenever you're setting up the joints. Okay, so let's look at how to create some rig options and controls for an animator, because weight painting is essentially the same process throughout the rest of the body. Those orientations are messed up, dang it. So after you paint full solid colors, you just can go back in, and what I generally do is, since we're on a weight a smooth value of 3 on the binding, we can just flood a little bit, and Maya will automatically disperse. Dang. Yeah, see, that's fine. So just hit the flood button 2 times on smooth, and it'll sort of smooth out our weight paints, so they create better deformation. So now you can see a big difference. It looks more stretchy, it doesn't look rigid, it's very natural looking. And obviously a lot can still be done to improve them, but it just takes time. So mirror that again. Okay, so now I'm just going to work on setting up the foot rig, and to do that we need to start adding some IK handles. That stands for inverse kinematics, and we want to do an IKRP solver, stands for rotation plane. With these we can actually control the direction that an IK is aiming, so that's good for knees and elbows, so we can give a little bit of rotation here. It rotates from up here, I should say, so we can get movement like that on the foot and the leg. So our first IK is going to come from the hip down to the ankle, and I'm going to go to my channel box so I can name these immediately. And this is left ankle IK, and then we're also going to go from the ankle to the ball of the foot. We'll do left ball IK, and then from the toe back to the ball of the foot. So this is left toe IK. Okay, so with those basically set up, I can show you if I just grab the ankle IK handle and move it. You can see, I should grab them all, sorry. You can see how these IKs work. They interact with the joint chain to create a smooth interpolation of rotation to create a more natural effect. They basically work as muscle tendons as well, so you can see I can't stretch the leg out any further than that point. The leg straightens out, and that's it. So to make these a little bit more robust and to make it feel more like a natural leg and easier on the animator, you can see how it sort of squashes the foot there. It doesn't look quite right. What I can do is, through a series of parents and groupings, make a rigged system that will allow for a lot more control. So first, I'm going to grab the left ankle IK and group it by itself, and I'm going to hold in D and V and then middle mouse button click to snap it to the center of the ball IK, or the ball joint, I'm sorry. So now when I rotate this, you can see he lifts up his ankle, comes up on the ball of his feet, looks like a natural movement. So I'm going to come over here and name this group left ankle pivot, and I'm going to grab the ball IK, or the left toe, I'm sorry, left toe IK, and Control G to group it by itself. Sorry, I didn't say that last time, did I? So Control G is the shortcut for grouping, and then we can name this one left toe pivot, and that should snap to the ball as well. So now he can tap his toe. Alright, so now we're going to grab all three, group them together. So grab both the groups plus the ball IK, group all of those together, and those are going to snap to the heel. So now he can come up on his heel, so we can call that left heel pivot. So these are just empty groups that we're parenting all of the objects under, all of the IKs under. And we're going to group that one again and put that to the toe. So now he can go up on his very tiptoes. So we'll call that one, since we already have a left toe pivot, we'll call this one left toe just group. And we're going to group it one more time so you can see our joint hierarchy here. And this one is just going to be left foot group. Snap that center point, holding in D and V, to the ball joint. And now we have this hierarchy completely set up. We need to make a control so we can grab the group easier, because obviously this group is empty. The only way we could get to it is by going into the hierarchy. That's really not very helpful for an animator. They want a control that they can grab onto. So I can go to my NURBS options or use a CV curve. I think I'm going to use a CV curve for the foot and make a little symbol that might help an animator out a little bit more than just a circle. So it's a foot control. We can sort of make a foot shape, or we can make an arrow. I'm just going to go with an arrow right now. And I have my tool settings to linear, so I will only be drawing straight lines. And I'm just going to use the grid to help me do this. So let's go ahead and draw out an arrow. And modify center the pivot point. And then I can hold in V, snap that to the ball joint, and then scale this down so that it fits the foot better. And then I want to freeze transformations before I parent the groups. So holding in the hypergraph hierarchy, you can middle mouse button click and drag an object and release it on top of another one, and it'll parent it underneath of it. So now, whenever I select this curve out in the scene, it'll select it in hierarchy, and everything underneath of it, which is parented, I can manipulate. So now we have a control to move our foot. We can rotate it and then we can set up custom controls to control these groups within it. So I'll show you how to do that real quick. I should name this curve though. I'll name it left foot control. And you use the same approach on the right foot. Like I said, you can't really mirror IK handles or joints or anything. And I'm going to grab these IK handles real quick, and I'm going to turn their visibility off. You can still find them in the hypergraph, but it's a little bit more convenient for an animator when they don't have a lot of stuff in their way while they're trying to grab curves. So I can save again real quick here, and then I'm going to start making custom attributes for this foot so we can control some more, we can manipulate it a little bit more. So looking at this foot, we can rotate it, we can translate it in any direction, we can scale it, but that's not really helpful, and we don't really want the animator playing with the scale of an object that they shouldn't scale. So what we can do is click and then just drag to select the rest of these. We don't want them to mess with visibility either. So we can then right click and lock and hide the selected attributes. So now they're locked out of our channel box. So you can see if an animator comes in and tries to scale this object, they're not going to be allowed because that attribute is locked and it's not editable or not keyable. Okay, so now we can add our own custom attributes by going to Modify, Add Attribute, and it brings up the Add Attribute window. And the first attribute we want to add is going to be the ankle pivot, or the ball rotation, so where he can get up on the the ball of his foot. So we can call that just ball rotation, and we want it to be a float type, which means that any same as in programming, it can be any value, decimal points included, between the two numbers. So our minimum number, let's say if we want him to push his heel into the ground as well, so that could be a different attribute. We can make that should be -5, and then 5, he'll be fully up on his foot, and then the default will be 0, his current state. So we can hit add, and you can see over here in the channel box it added this new attribute. And you can do this, you can make as many custom attributes as you'd like, and the way that we're going to control this is by using set driven keys. So just under animate, set driven key, set window, and brings up the set driven key window. And what we want is to tell the new control that we made what it's going to be driving. So first we want to load our driver, which is our left foot control, and we want that to control the ankle pivot group that we made earlier. So we're going to go into the hypergraph hierarchy to select that group and hit load driven. So now we have our ball rotation and our ankle pivot selected over here, and if we grab the ankle pivot within the set driven key window, and let's see what rotation we need to rotate it on the X. So I have my ball rotation and left ankle pivot on rotation X set at default position with a 0 on rotation X, so we're going to hit key. So now if I change the ball rotation to 5, we want to tell Maya what the new position of the left ankle pivot should be whenever that value is 5. So I'm going to rotate this up, make it come up pretty far, because we never know, the animator might need it that far, they might not, so they can play with anything in between since it's a float value. So with ball rotation at 5, ankle pivot at 60, we're going to hit key again. So now if we go back to the foot control, we can change this from 0 to 5, and you can see that it'll actually manipulate the joints. And I can just scrub between these the numbers here. You can see it happening. Okay, so now let's play with -5. We're going to come back down here, and let's say we want him to straighten out his leg like that when it's at -5, like he's trying to stop really hard or something. His heels go down into the ground. So we can hit key. And now we have from 5 to 0, 10, -5. So we have all these new controls that we can add. We can even do it with the tip of the toe as well. We could do it with the heel, so he can have a custom control for each of these different attributes. So that's the basic premise behind it, basic way you do it. If there's any other specific questions, I'd be glad to answer them. I'm going to stop for now, and I'll do a second video on the different types of constraint options that are involved in rigging a mesh. So, thanks for watching. Stay tuned for more.